All right, let's look at some examples of inverse functions and how this all works. If you remember, inverse functions are functions that undo each other. From the last video. Now let's do a little basic example of what inverses are. In my blue box, let's say that we're going to input the number 6 into our function x plus 5. Well, we all know that if you put 6 in for x, the output would be 11. You put in 6, you got 11 out. Now, the inverse function of what we just did, and you notice that little -1, that little -1 means inverse. That means if I take 11 for my input and I put it into some function, I got to get an output of 6 because my inverse has to undo what my previous function just did. Well, I put 6 in for x and got 11. So obviously if I take 11 and I'm going to get 6, my inverse function better be x minus 5. Because 11 minus 5 is 6. These two functions undo each other, which means they are inverses. All right. Hope we established that. Now, let's do some mathematical stuff. Example number 1. In order to find the inverse function of a function, here are your 2 steps. A, you need to switch the letters x and y around, and then B, once you do that, solve for y. So, here's our function. F of x equals the cube root of x minus 7. I'm going to put that in my little chart over here. The cube root of x minus 7. That's my function. I need to find its inverse. Well, in order to do that, I take the x, and of course we know f of x is y. I'm going to switch these 2 letters around. So therefore I get x equals the cube root of y minus 7. And now I need to solve that for y. Well, the first thing I got to do is I got to get rid of the cube since the y is underneath the cube root. So I'm going to cube both sides. So now I get x cubed equals, and this cube and cube root will cancel out, so I have just y minus 7. And finally, I'm going to add 7 to both sides, and those cancel out, and I get what's in my circle. Y equals x cubed plus 7. And that would be my inverse function. Here's my function. Here's its inverse. I hope that makes sense. That's all you got to do. All right, let's look at a second example. It says graph y equals x squared plus 3. Okay, let's do that. Make a little t-table. I'm going to pick, we know it's a parabola since it's squared. So let's go -3, -2, -1, 0, 1, 2, 3. And let's plug these numbers in. If you put -3 in there, -3 squared is 9, plus 3 is 12. If I take -2 and stick it in there, I get 4 plus 3 is 7. If I stick -1 in there, I'll get 1 plus 3 is 4. I put 0 in, I get 3. I put 1 in. 1 squared is 1 plus 3. I think you see the pattern here. We've done this before. So I'm going to plot my points. -312 and +312 are off my chart, but -2, 7 is right there. -1, 4 is right there. 0, 3 is right there. 1, 4 is right there. And 2, 7 is right there. So if I graph this, you'll get your parabola, which we did in Unit 5. And there we go. Beautiful. All right, find its inverse. Well, the last slide told us if we're going to find its inverse, we need to take x and y and switch them. Okay, so let's do that. If we switch it around, I get x equals y squared plus 3. And now we're going to solve. And so we're going to minus 3 from both sides. We get x minus 3 equals y squared. And to undo the square, we do the square root. And therefore, our inverse function, y, is equal to the square root of x minus 3. Now, if I wrote it properly, I'd say f inverse of x is equal to the square root of x minus 3. So there we go. Now it says graph its inverse. All right, well, let's make a t-table again. Graph its inverse, x and y. Now, we're going to be really smart about this because only certain numbers can be put in for x. Obviously, I can't put in anything smaller than 3 because if I put 3 in there, or if I put 2 in there, you get a negative number and we are in the imaginary number system. So we're going to be smart about this. The smallest number I can put in there is 3. Well, if I figure that out, the square root of 3 minus 3 is equal to the square root of 0, which is 0. Now, we're going to pick numbers that work out nicely. 4. Now, I can put a 4 in there, and what I'm going to get is I'm going to get the square root of 4 minus 3, which is the square root of 1, which is equal to, and we actually in this case have positive 1, or we could have negative 1, because remember it's plus or minus when you solve these guys. Okay, well, now what's our next really good number? I think 7 is probably the next really good number we can put in there, because the square root of 7 minus 3 is the square root of 4 plus or minus, which is going to be plus or minus 2. So I can have 7 and 2 and 7 and negative 2. Now let's graph those points and see what it looks like. The point 3, 0 is right there. The point 4, 1 is right there. The point 4, negative 1 is right there. And the point 7, 2 is right there, and 7, negative 2 is right there. Oh, we get a parabola that's turned sideways. Well, if you recall, though, from the last video, to graph an inverse, we flip it across the line y equals x. Well, if I put that dotted line in there, there it is, people. There's that dotted line, and if you notice, the blue graph is a mirror reflection of the green graph. So therefore, we do have the proper inverse function. There it is. That's our inverse function of that function, and we've proved it on the graph.